All right, so ready to go. So can you see the question clearly?
Yes, sir.
Good, good, good. Right. What about you, Camelia?
Yes, sir.
All right. So this question, as I mentioned before, is from January 2024, and we're going to be focusing on question 8, which deals with algebra relations, functions, and graphs. Right. Now, years ago, section 2 used to give you options to do 2 questions from 3, but that is no longer the case. They now require you to do all questions in section 2, which means you're required to do all questions on the paper. Okay. All right. So this first part of the question says the diagram below shows graphs of 2 functions on the same pair of axes. The lines G and H are perpendicular, right? So we should be able to tell certain information from that piece of, or we should be able to draw certain conclusions from that piece of information there that the lines are perpendicular. So this right here is very important, right? Lines are perpendicular. So we want us to determine the equation that represents the line G. Now let's look at the line G. What information do we have for the line G? Do we have the y-intercept for G? First of all, do you understand the meaning of the expression the y-intercept?
Uh,
Yes, sir.
So yeah, the y-intercept, of course, is a value where the graph cuts the y-axis. So with that said, do we have the y-intercept for the line G?
Yes, sir.
yes,
What is the value?
3.
3.
3. So we can basically say that for the line G, we have the y-intercepts, and we usually use the letter C to represent the y-intercept. So this is equal to 3. So because generally the equation of a straight line is often expressed in the form y equals mx plus c. So this, we often represent this as equation of a straight line, where of course m is the gradient or the slope. So m is the gradient slash slope, and of course c is equal to the y-intercept. So one thing we should know about the y-intercept is that at that value or at that point, the x-coordinate has to be 0. So we can say that the y-intercept is therefore the point 0, 3, right? Do we have the coordinates of another point on line G?
Please repeat that.
Do we have any other coordinates of a point on line G?
Sir, do you have the x-intercept?
X.
Right. So we have what we commonly refer to, we can refer to as the x-intercept. Some people refer to as a root. That is, of course, where the line cuts the x-axis. And of course, at that point, the y value will be 0. So we also have a second point, -6, 0. Is that clear?
Yes, sir.
Yes, sir.
So what do we do with those 2 points? Whenever we have 2 points on a line, then what we should basically do with those 2 points is to find the gradient of the line. So therefore, we're going to say that the gradient of the line G, so the gradient, and we write down a little gradient formula, is y2 minus y1 divided by x2 minus x1. So typically, we can let any point be x1, y1, but for a line sloping like this, we let this point, lower point, be x1, y1, and the upper point, that right there, be x2, y2. So basically, our 0, 3 is our x2, y2. So label it as x2, y2. And our -6, 0 is our x1, y1. So therefore, what this means is that the gradient is equal to 3 minus 0 over 0 minus -6. You have to be careful when subtracting, especially negative numbers. Many times students tend to omit one of the negative signs because they already see a minus sign, and so they actually fail to actually introduce a second minus sign, which of course is necessary. So this gives us 3. These two signs, or these two minus signs, combine to give a plus. So that's 3 over 6, which is equal to a half, or 0.5. So that right there is the gradient, okay? Now, typically, when we want to write down the equation of a straight line, we find the gradient and we say y equals mx plus c. In most cases, or in many cases, we don't actually have the intercept, the y-intercept directly. So what we normally do is to substitute one of the given points and therefore and the gradient and then solve for c. But in this case, we already have c, and therefore having found the gradient of the line and having determined the value of c from the graph, then we can write down the equation. The equation is y is equal to a half x plus 3. Is that clear?
Yes, sir.
Yes, sir.
Good. So that is the equation of the line G, y is equal to a half x plus 3. Now let's see what it asks us in the next part of the question. In the next part of the question, they want us to find the equation that represents the line H. Now let's look at the line H. What information do we have about the line H from the graph directly?
Sir, of the x-intercept.
We have the x-intercept, of course, which is 4. So we have a point on the line. So we have a point on the line. Let's write down this point. So we have the point on the line, which is the point 40, which of course referred to as the x-intercept. Do we have any other information pertaining to this line? Because we need more information before we can actually write down the equation of the straight line. Now remember, equation of a straight line is given as y is equal to mx plus c. So we do have a point on the line, but we need more information. In order to determine the equation of a straight line, typically we need a combination of one of these things. Point on the line, or we could say the coordinates of a point on the line and the gradient, right? So we need a coordinate of a point on the line and the gradient, or we need the coordinates of 2 points on the line. Right? Do we have any of these? Is any of these conditions satisfied? Let's check. Do we have a point on the line? Yes, we do. Do we have the gradient? Technically, we don't, but can we determine it? Yes. So we have a point on the line. We don't have the gradient directly, but we can find it. How can we find it? We were told that the two lines are perpendicular. And that is how we actually use that information to find the gradient of line H. Now let's talk about perpendicular lines. What do we know about perpendicular lines? Well, obviously perpendicular lines intersect at right angles, but we need some more information. Now, typically we say that if two lines are perpendicular, so if two lines are, I'll just put that sign for perpendicular, the product of their gradients, the product of their gradients is equal to -1. That is a property. If two lines are perpendicular, the product of their gradients equals -1, or we can say that the gradient of one line is the negative reciprocal of the other, or of the gradient of the other. What exactly does this mean? It means that if M1 and M2 are the gradients of two perpendicular lines, then it means that M1 times M2 is equal to -1, or we can say that M1 is equal to -1 over M2, or even that M2 is equal to -1 over M1. Okay?
Yes, sir.
So
Yes, sir.
whenever we talk about perpendicular lines, we know the product of their gradient is equal to -1. So the gradient of one line is equal to -1 over the gradient of the other line. That is what we mean by the negative reciprocal. So in part one of the question, we calculated the gradient of line G. which worked out to be a half or 0.5. Since line H is perpendicular to it, the gradient of line H, let's call that M, or yeah, the gradient of line H is equal to minus 1 divided by 0.5, which is equal to minus 2. Is that clear?
Sir, repeat.
In part 1 of the question, we found the gradient of line G to be 0.5. Remember that?
Yes, sir.
And we're told that the two lines are perpendicular. We just established that if two lines are perpendicular, the gradient of one line is a negative reciprocal of the gradient of the other. So therefore, this means that the gradient of line H is equal to minus 1 over the gradient of line G. So that's minus 1 divided by 0.5, which of course gives us negative 2. Okay?
Yes, sir.
So having determined the gradient of line H, we have now satisfied this condition in order to find the equation of the line. We have a point on the line, and we also now have the gradient of the line. Good? So what can we do now? We can basically write down our equation, y equals mx plus c. We can substitute the coordinates of the point and the gradient into the line and then solve for c. So this is our point right here, 4, 0, and of course it's always in the form xy. So if substitute those values, what we get is this. We see that 0 is equal to minus 2 times 4 plus c. So 0 equals minus 8 plus c, and therefore this means that c is equal to 8. And having found the value of the y-intercept c, the equation, of course, is going to be of the form y equals mx plus c, and so we have y equals minus 2x plus 8. Any question?
No, sir.
Yes, sir.
Right? So we need to remember that if lines are perpendicular, the gradient of one line is a negative reciprocal of the gradient of the other. And of course, you know that in the case where they're parallel, the gradients will be the same, right? So if you're told that two lines are parallel and you have to find the equation of one of the lines, then of course the gradients are equal. Good? Now let's look at part 3 here. Part 3 says we want us to determine or to find the coordinates of the point P show all working. I imagine that P is where the two lines actually meet. Yes. So here we are. We have the two lines intersecting at P. Now, whenever lines intersect and we want to find the point of intersection, we simply solve the equations of the two lines simultaneously. So here we have the equation of line G. Y equals a half x plus 3. We're going to solve that simultaneously with this one here, y equals minus 2x plus 8. So let's write down our two equations. Our two equations are y equals minus 2x plus 8 and y is equal to a half x. What was this one again? Half x plus 3. Right? So we can solve these two simultaneously. Generally, there are two common methods of solving simultaneous equations. Kamari, can you tell me one of them?
Elimination.
Right. Camila, can you tell me the other one?
Substitution.
Good. So those are the two common methods of solving simultaneous equations. Now, in this particular case, since you already have the two equations being expressed as y in terms of mx plus c, we can just equate the right-hand side and proceed to solving. So we can say that minus 2x plus 8 is equal to a half x plus 3. We bring all the x terms to one side. So we can say minus 2x minus a half x, and we bring the constant to the other side, equals 3 minus 8. So minus 2x minus a half x, that's basically minus 2.5x, or minus 5 over 2 times x, which gives us minus 5. So therefore we have 5x over 2 is equal to 5, which therefore means that x is equal to 2 times 5 over 5. Or what we could have done also, we can just strike through the fives. Can strike through the fives, and this gives us x over 2 is equal to 1, which means that x is equal to 2. So that is the x coordinate of the point P. We need to find the y coordinate because the specifier asks us for the coordinates of the point P. To find the y coordinate, we can substitute x equals 2 into any of the two equations we just used. Let's use the first one. So y equals minus 2x plus 8. So y equals minus 2 times 2 plus 8. Y equals minus 4 plus 8. And so y is equal to 4. So therefore the point P has coordinates 2, 4. Is that clear?
Yes, sir.
Yes, sir.
Right? So that is how we do that question there. So this question involves quite a few things, a little bit of coordinate geometry, find an equation of a line, equation of perpendicular lines, simultaneous equations, and all of that, right? So this question normally combines the different little parts of the syllabus. All right, that part there deals with straight line equations and coordinate geometry. All right, part B. Part B says write 4x squared minus 24x plus 31 in the form a open bracket x plus h all squared plus k. So when we're told to write something in that form, what really are they telling us to do? What is the expression for what we are required to do here? What is it called? Anybody
Factors.
knows? Huh?
Is it factors?
No, not factorize. Camelia, you wanna try?
Um, sir, I got nothing.
Right, completing the square. That's what we're required to do, complete the square. So whenever you're told to express a quadratic, which of course this is, 4x squared minus 24x plus 31, in the form a, open bracket, x plus 8 squared plus k, sometimes you might see x minus h, you might see x minus k, any other letters can be used. But essentially what you're required to do is to complete the square, right? And we have done algebra, and I think I remember doing completing the square, right? Well, let me go through this question. So for the sake of this question, I'm going to say let f of x be equal to 4x squared minus 24x plus 31. I'm going to put the plus 31 over here by itself for a little reason. Right. Now, whenever we are required to complete the square of a quadratic, we must first check the value of a. Now, remember that a quadratic is generally of the form quadratic equations of the form, say f of x is equal to ax squared plus bx plus c. If you compare those two equations, what is the value of a?
Um,
Hmm? What is the value of
4,
a?
4,
Camila? Sorry, repeat.
sir, 4,
Yes. Kamar, you said one?
four,
What did you say? I didn't hear. Did you say four or one?
four.
4, that is correct, yes. So the value of a in this case is equal to 4. Which means that we cannot proceed to completing the square just yet. We have to do something else first. We can only complete the square of a quadratic where a is equal to 1. So let me repeat that. We can only complete the square of a quadratic when a is equal to 1. If a is not equal to 1, we must first factor out the value and get an expression where a is equal to 1. So this is what we're going to do here, right? We're going to say that f of x equals, I'm going to factor out the 4. Now, some teachers factor the 4 from the entire quadratic. I tend to just factor out the value from the first two terms. So that just makes it a little bit less complicated. So I'm going to factor the 4 from the first two terms. So inside I'm going to get x squared minus 6x, right? I'm going to leave some space inside the bracket there. I'm going to put my plus 31 out here. Okay? Everybody with me so far?
Yes,
sir.
sir.
All right, so now I'm going to basically compare this expression inside the brackets now to ax squared plus bx, right, plus c. So what is the value of a for this expression inside the square brackets?
1.
That is now 1. Good. What is the value of b?
-6.
B is
Negative
negative 6. Very good. What is a half of negative 6?
-3.
Very good. So let's proceed. Right? I asked you those questions for a reason. So now I'm going to say that f of x equals, I keep my 4 outside, my square bracket, x squared minus 6x. Now I'm going to do this. I'm going to say this is going to be plus minus 3 squared. And I'm also going to subtract minus 3 squared. Why do I have to do that? That is a necessary step in completing the square. We must add a half of b squared, but adding it will change the expression, and so we must also subtract it, right? Let me repeat. Completing the square requires you to add a half of b squared to the quadratic, but when you do that, you're changing the expression, and so you must subtract it to make sure they cancel out each other, but it will still allow you to express it in the desired form. I'm going to waste rules then, man. Alright, let me soon start putting that pot. Well, I'm nice and destroyed. Anyways, so yes, right? So the plus 31 comes back outside. So when completing the square, of course, we have to add a half of b squared, but we must also subtract it to ensure the expression does not change, and then we can proceed. Now, having done that, what will happen is that these first three terms, these will now form what is called a perfect square. Right? So these first three terms will form a perfect square. So watch me now. What we have is this. We have f of x is equal to 4. I'm going to keep my square bracket for a while. And inside here now, this becomes x. I'm going to write this using a particle color for a reason. Minus 3 squared. So those first three terms works out to give minus 3 squared. And outside here, now we're going to have minus 9. Right? Minus 9. And we have plus 31. So now we just expand our brackets. And so we get f of x is equal to 4 bracket x minus 3 all squared minus 36 plus 31, which of course equals 4 bracket x minus 3 all squared minus 5. So this now is in the form a x plus h squared plus what is it? Is plus k they said? That's it? Yeah, I think it's plus k. So a open bracket x plus h all squared plus k. That is it. Questions?
No, sir.
Do you understand what I did?
Yes, sir.
Right? So let me run through it. Did somebody else join, or was it one of you got kicked out and rejoined?
So I just joined, sir.
Oh, that's Renako.
Yes, sir.
All right, cool, yeah, man. So we're looking at past paper questions, of course, from section 2, specifically those in algebra relations and functions and graphs. So we did the first part of the question already. We're on to the second part. You just have to watch the first part of the recording later and catch up, right? So we did this little piece of the question here on completing the square, where they basically told us to express or to write this part here. They told us to write 4x squared minus 24x plus 31 in the form a open bracket x plus h all squared plus k. And we basically say that when you see instructions like those, what you're expected to do is, this means to complete the square. Complete the square. That is what you're expected to do for this quadratic. Complete the square, and we went through the process, right? So said we wrote it down. So f of x, we just said let f of x be equal to 4x squared minus 24x plus 31. And we say that the value of a is equal to 4. And so we cannot proceed to completing the square because a is not equal to 1. So what we had to do was to factor out the 4. And so we got this expression inside, right? Where a is now equal to 1 and b is equal to minus 6. So b is equal to minus 6. A half of b is therefore minus 3. And in order to complete the square, we must add minus 3 squared, but we must also subtract it to ensure the expression does not change. So basically, these two terms essentially cancel out each other, but their presence allows us to complete the square and to express a quadratic in a certain form, right? Now, these first three terms that I highlighted with the white curly brackets, they form what is called the perfect square, which of course is this right here. This, of course, is the perfect square that they form, okay? That is x minus 3 all squared. And of course, we have the minus 9 outside. We then expanded the brackets or multiply through by the 4 outside. So get 4 x minus 3 all squared minus 36 plus 31, which simplifies to give 4 x minus 3 all squared minus 5. So sometimes they may ask us to actually state the values of h and k and so on. So if we were required to do that, it means that a equals 4, h is equal to negative 3, and k is equal to negative 5. Now, what is the significance of this completing the square thing? Now, whenever you express a quadratic in this form, you should be able to read off the coordinates of the turning point of the quadratic. So let me write down the turning point and see if you can actually see how I arrived at it. So the turning points of this quadratic, sometimes you may see the turning point, you may see the word vertex and so on. This is actually 3 minus 5. Do you see where I got those numbers from?
Yes, sir.
Right? So
Yes.
once you express it in the form a x plus h all squared plus k, the x coordinate is whatever is being subtracted here. So that would be 3 is being subtracted. So therefore the x coordinate is 3. And of course the y coordinate, of course, is a number outside, which occurs when x is equal to 3. So the turning point is 3 minus 5. Now let me just do another one since you're on the topic of completing a square. Suppose we have a quadratic which is in this form. F of x is equal to, say, 2x plus 5 squared minus 19. Who can tell me what the turning point of this one would be? Who can tell me that?
5 and negative 19.
Repeat that, please.
Is it 5 and negative 19?
Not 5, but
Negative 5.
negative 5. So the
Oh.
turning point is minus 5 minus 19. So whenever if it's a plus sign inside here, the turning point is minus. If it's a minus as we have over here, its turning point is positive. So it basically is whatever is being subtracted. Now, if you think of x plus 5 essentially the same thing as x minus minus 5. We could have written it like that. And then we have minus 19, but we don't normally write it like that. So think of it this way. The x coordinate is whatever the value of x, which makes this equal to 0. So whenever you want to find the x coordinate, equate this to 0 and then solve for x. You understand?
Yes, sir.
So
Repeat.
whenever you want to find the x coordinate is the value of x, which makes this expression inside the bracket 0. So you set this to 0, x plus 5 equals 0, so x is equal to minus 5. That is therefore the x coordinate of the turning point. We could have done the same thing over here. We could have said x minus 3 equals 0, so x is equal to 3, and that is, of course, the x coordinate of the turning point. Okay?
Yes, sir.
Sometimes they will tell you to use express it in the form x plus h all squared. Sometimes they might put x minus h all squared. It should not confuse you. Okay?
Yes, sir.
Right.
Yes, sir.
All right. So let's go and finish the next part of the question. All right. So we express it in that form. So we could say that this, of course, this f of x, call it f of x, equals 4x minus 3 squared minus 5. All right, the next part now look like we want us to do a sketch. On the axis below, sketch the graph of 4x squared minus 24x plus 31, indicating the coordinates of the maximum or minimum point and the y-intercept, right? So these things, as I mentioned before, you should have the ability to read off the turning point, which we just did. And of course, the y-intercept. For any graph or any function, the y-intercept occurs at what value of x? At what value of x does the y-intercept of any function occur?
0.
0. So the y-intercept is basically f of 0, and you can clearly see that from this equation, 4x squared. If we say f of x equals 4x squared minus 24x plus 31, then f of 0 is the constant term, which is 31. So f of 0 equals 31. So therefore, the y-intercept is 31. All right? Now, we should have knowledge of the shape of quadratics. So remember that a quadratic is of the form, say, f of x is equal to ax squared plus bx plus c. When a is positive, that is greater than 0, it shapes like this. It's a smile then. It's a smile, right? However, if a is negative, it shapes like this, is a frown, right? A long face. You must remember that. So when a is positive, it's a shape like this. It opens upwards. When a is negative, it opens downwards. So you must remember that. In this particular case, a is equal to 4. So it's going to be a smile. In other words, it opens upwards. So let's go ahead and try to do our little sketch. They didn't tell us to indicate any other information apart from the y-intercept and, of course, the maximum or minimum point, which, of course, is a turning point. As we established, this is a turning point right here, 3 minus 5. And we could have read that off from the completed square version. So doing this sketch, gonna look something like this. So this, something like this. So this value, of course, here would be 31. All right, this is supposed to be a little bit more symmetric. Let me try to draw it a little bit better. All right, that's a little bit better. So this value right here is 31, and this point right here is 3 minus 5, right? 3 minus 5. The line x equals 3 is referred to as the line of symmetry. So when we speak about the line of symmetry of any quadratic, it's basically the vertical line through the turning point. I know my line missed it, but it was meant to go to the point, okay? What does it mean by the line of symmetry or the axis of symmetry? Is that clear?
Yes, sir.
So when we speak about the line of symmetry of a quadratic, it's the line which basically cuts the curve in two halves, and it is a vertical line through the turning point. The turning point is x is a point 3 minus 5. So the line of symmetry is x equals 3. The line x equals 3. Good? So the line x
Yes.
equals 3 will divide the quadratic into two halves, hence it's called the line of symmetry or the axis of symmetry. In other words, then the graph or the curve is symmetric about that line, right?
Yes, sir.
Right? So yeah, so even though the question didn't ask about a lot of that, we are able to, oh, watch this. I didn't even see this part down here, right? So state the equation of the axis of symmetry. That equation is x equals 3. Okay? So the equation of the axis of symmetry is always x equals something when you talk about a quadratic, right? And it is the x coordinate at the turning point, right?
Yes.
All right, so this is the end of this question. This is from January 2024. Let's scroll up to another question. All right, this one is from June 2022. I was searching, but I didn't find June 2023 paper. I will keep searching and see if I find it. All right, same topic, algebra, relations, functions, and graphs. This one looks like gonna deal with inequalities, right? So let's talk a little bit about inequalities. What is an inequality? An inequality basically is a statement that one quantity is greater than, less than, could be greater than or equal to, or less than or equal to another. So if you write x is greater than or equal to 5, that's an inequality. X is less than -4, that's an inequality. P is greater than or equal to -2, that's an inequality. We can write -2 is less than x, which is less than or equal to 5. I mean, when it comes to plotting graphs, sometimes we're given the domain of the function in such a manner. So for instance, say -2 less than or equal to x less than or equal to 5. And this would mean that x lies between -2 and 5 inclusive. So we'll take values -2, -1, 0, 1, 2, 3, 4, 5, and so on. So these are all examples of inequalities. Now, inequalities, of course, and straight line graphs are very much related. And we can represent the region satisfy an inequality using the graphs. Now, you need to be able to understand that. You need to be able to graph inequalities. Now, you have to understand the x and y axes. I will just draw a pair of x and y axes here. Let's do a thing. Right, so here we have pair of x and y axes. So this, of course, is y. Let this be x. Now, we know that at any point on the x-axis, y equals 0. So all along the x-axis, y is equal to 0. Similarly, all along the y-axis, x is equal to 0, right? We can have, all right, so suppose you have something like x is greater than 0. X is greater than 0 would occur to the right of the y-axis. So I'm going to shade the region x is greater than 0. So anywhere over here, x is greater than 0. All of that, x is greater than 0 to the right of the y-axis. If I want x less than 0, it's on the next opposite side. X less than 0. All over here, x is less than 0, right? Now, if I want, say, y greater than 0, y greater than 0, that would be above the x-axis. Let me see, which color should I use now? Let me use this one. Y is greater than 0 is above the x-axis. You understand? Above the x-axis. And naturally, y less than 0 would be, which color have I not used? Y less than 0 will be down here. So you need to be able to associate an inequality with a particular region on the x and y axis or on the coordinate axes, right? And sometimes we're going to have things like, for instance, suppose we say, for instance, we want to represent y is less than or equal to 5. If we want to represent y is less than or equal to 5, let me just erase some of these here. Well, all of them. Suppose we want to represent the inequality y is less than or equal to 5. The first thing we have to do is to draw the line y equals 5. Now, let's say, for instance, and of course, the line y equals 5 is a horizontal line parallel to the x-axis. So let's say this is the line y equals 5. So this is the line y equals 5. Now, because y is less than or equal to 5, the region satisfying that inequality is going to be on or below the line. Right? So this is the line y equals 5. So y is less than or equal to 5 corresponds to on the line and below the line. Is that clear?
No. Wait, no, sir.
So y is less than or equal to 5. This means that y is equal to 5 or less than 5. So it's going to be 5 and on the line y equals 5 and below the line. Okay? Now,
Yes, sir.
suppose I want to represent something like this now. Suppose I want to represent x is greater than, say, negative 3. The first thing I must do is to sketch or to draw the line x equals negative 3. And let's do that. Let me just draw a line there to represent x equals negative 3. Now, suppose this is the line x equals negative 3. X equals negative 3. I'm making the line broken. So I'm erasing sections of the line because the line needs to be broken. Why? Because we want to represent the region where x is greater than negative 3. If x is greater than negative 3, is negative 3 included in the set of values, possible set of values?
No, sir.
No. So if x is greater than negative 3, x equals negative 3 cannot be included. And for that reason, we draw the line broken. So whenever it's just a greater than or less than sign, we use a broken line. However, if includes or equal to, we use a solid line. Okay? So let me just change back this again. So let me just erase these green regions that show original thing. Right? So if I want to show x is greater than negative 3, I use a broken line, and then of course I will shade the region to the right of the line. So all over here is showing x greater than negative 3. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So horizontal lines and vertical lines are usually easy to deal with. Let's look at some lines now which are sloping. Right? Suppose we're asked to represent, show the region satisfying the inequality. We're going to make up one now. Say y is greater than or equal to 2x minus 6. Now, before we can actually show that region, we need to be able to show the line y equals 2x minus 6. We need to be able to show the line y equals 2x minus 6. How do we show that line? It's going to be a sketch. If we want to sketch the line y equals 2x minus 6, we just need to have two simple points on the line. We could say when x equals 0, then y of course is equal to minus 6. So therefore we have the point 0 minus 6. And we can pick another simple value. Say for instance x equals 3. When x equals 3, then y is equal to 6 minus 6, which is equal to 0. So we have the point 3, 0. And we basically try to locate those points. Usually we have our graph paper, so we can actually draw it to scale. So should I, all right, let me use a little grid. Let me use a little grid in here. All right, yeah, so let me, all right, so yeah. Right. So let that be my little thing now. So let me just use a little scale thing to show the points, right? So these are my points. So let me see the point 0 minus 6. So obviously this is the origin here, 0, 0. Let me see 1, 2, 3, 4, 5, 6. So this is the point 0 minus 6. And the other point is 3, 0. So 1, 2, 3 right here, right? So this point is 0 minus 6. And this one is 3, 0. So all I need to do now is to draw a line connecting those points, and I'll do that. All right, are you seeing my line I'm drawing?
Yes, sir.
All right, so that is my line representing y equals 2x minus 6. Now, if I want to show y is greater than or equal to 2x minus 6, equal to 2x minus 6 means on the line. Greater than 2x minus 6 is going to be above the line. You understand? And because it's or equal to, I use a solid line. So I must now shade the region that is on or above the line. We're talking about this region here. So that region is above the line, y equals 2x minus 6, and therefore represents my inequality. Okay?
Yes,
Yes,
sir.
sir.
So that is basically what we have to do. Whenever we have an inequality, we try to sketch the line associated with the inequality and then ask ourselves, are we interested in the region above this line, below this line, in the case of a slanting line, or in the case of a vertical line to the right or to the left, in the case of a horizontal line above or below? Those are questions we must typically ask ourselves, okay? All right, so having said that now, let's look at the information required of us in the question. It says a rental company has X cars and Y minivans. So X cars and Y minivans. Um, X cars, Y minivans. The company has at least 8 vehicles altogether. What does the expression at least mean? At least implies greater than or equal to. Whenever you see the expression at least in terms of inequalities, this translates to greater than or equal to. Is that clear?
Yes, sir.
Another way of expressing at least, they could say no less than or no fewer than. These are similar expressions. So if they say that the company has no less than or no fewer than or at least, they basically mean the same thing. Is that clear?
Yes, sir.
Right? So now just diverting from the question for a little bit. Suppose we see at most. What does that mean in terms of an inequality sign? That means less than or equal to. So suppose, for instance, your mother give you $100. Well, it can't be Jamaican dollars. But anyways, let's say she give you a 5,000, right? Say you got champs. Your mother said, right, well, a 5 grand, but don't spend no more than, or she said spend at most 3,000. What is, should you spend 4,000? If she says spend at most 3,000.
No, sir.
So
No,
it's going to
sir.
be 3,000 or less. So therefore, at most is less than or equal to, okay? And another way of expressing at most is to say no more than, right? So no more than, or say no greater than. So these expressions are similar. They imply or convey the same meaning. Most, no more than, no greater than, and that of course implies less than or equal to. At least, no less than, no fewer than, that implies greater than or equal to. Right? So let's go directly to the question now. So the company has X cars and Y minivans. So in terms of the total number of vehicles, we must add those two numbers together. So X cars, Y minivans, and the company has at least 8 vehicles altogether. The first inequality is X plus Y is greater than or equal to 8. Do you understand that?
Yes, sir.
Amelia?
Yes, sir.
Ronako?
Yes, sir.
Good. Let's move on to the next part. The number of minivans, let me clear that up. The number of minivans is less than or equal to the number of cars. Read it again. The number of minivans is less than or equal to the number of cars. What letter represents the number of minivans? X or Y?
Y, sir.
And what letter represents the number of cars?
X, sir.
So the second inequality is Y is less than or equal to X. Okay?
Yes, sir.
The last statement that is of importance says the number of cars is no more than 9. So again, give me a synonym or a similar expression for no more than. What does no more than imply? Give me a similar expression. I would have given you 2 earlier.
At most.
At
Most.
most, right. So no more than means at most. And in terms of an inequality symbol, is going to be less than or equal to. Okay? So the
Sir.
number of cars is no more than 9, and therefore our third inequality is X is less than or equal to 9. Right? So there are our 3 inequalities. Good?
Yes, sir.
Right. Let's move to part B. A car can carry 4 people and a minivan can carry 6 people. There are at most 60 persons to be taken on a tour. So let's say you're going on a tour, an excursion, you're going on a trip, right? In terms of the number of vehicles, you have X cars and of course Y minivans. If you have X cars and you can only put a maximum of 4 people in a car, well, so 4 people. Give me an expression for the number of people carried by the cars. So X cars, 4 persons per car. Expression for the number of people in cars.
Kirby.
You go on a trip. You have X cars. You have X number of cars is X. Each car can carry 4 people. Give me an expression in terms of X for the number of persons traveling by car. So that's a problem with algebra. Just because I mentioned the variable X, it sounds confusing. But if I say if you're a group of 5 cars and each car carries 4 people, how many people in total will be going in cars?
20, sir.
Yeah, it's the same principle. You multiply. Right. So if there are X cars and 4 persons per car, what is the expression for the people traveling by car?
4x.
4x. Yes. Good. So we have X cars, the company, and 4 persons can travel by car, can carry 4 people. So we say 4x. We have Y minivans, and each minivan can carry 6 people. So therefore, it's going to be 4x plus 6y. There are at most 60 persons. So that means that 4x plus 6y, which represents the total people carried by cars and minivans, that must be less than or equal to 60. And what do we do to simplify? We simply divide through by 2. And so dividing by 2, we get 2x plus 3y is less than or equal to 30. Right?
Yes, sir.
So these topics require you to reason. You're given worded expressions and you're expected to translate them into mathematical expressions, equations, or inequalities. Okay? All right, let's move on to the graph part of the question now. On the grid below, plot the 4 lines associated with the inequalities in A and B. Shade and label the region that satisfies all 4 inequalities. All right, so I don't think I need my grid anymore, so I will take off the grid from this thing here because it can be a little bit confusing to look at. All right, so first of all, let me just jot down my 4 inequalities. Let me just copy these here. Oh, it's in black, so you're not going to show it in these. I'm just putting. Oh. All right, so these are 3 of my inequalities. Why this thing like it gets smaller? Like this one. All right, so these are 3 of my inequalities. Now remember I told you that in order to show the region satisfied by an inequality, you must first identify the straight line associated with that inequality. So let's look at this one. So we want to represent the inequality x is less than or equal to 9. The straight line is x equals 9. So we must first show on our graph the line x equals 9. So, prompt for minute something and start freeze up on here. All of a sudden, you start freeze up, John. All right, so I'm going to draw the line x equals 9. So this goes right here. So this is the line x equals 9. Should I leave it solid or should I make it broken? Look at the inequality and answer that question. X is less than or equal to 9. So should I leave the line solid or should I make it broken?
Solid.
Solid, because it includes the or equal to. Remember, we use broken lines whenever it's just greater than or less than. But if it's greater than or equal to or less than or equal to, we use solid lines. So basically, right, so yeah, this right here is the line x equals 9. Because the inequality wants to show x is less than or equal to 9, that region is going to be below this line, but we don't shade it as yet because the shaded region must satisfy all our inequalities. Okay, let's do the next one. The next line we must deal with, or the next inequality, is y is less than or equal to x. And of course, the line for this is y equals x. So let me draw the line y equals x. Now, the line y equals x is easy to draw. We just pick x and y values which are equal. Say, for instance, well, 0, 0 obviously is 1. And say, for instance, other points, say 5, 5, 5, 5 must pass through 5, 5, right? And so on, right? 10, 10, right? So the line y equals x. So let me draw that line now. right? So this is the line, y equals x. And because I'm interested in y is less than or equal to x, that is going to be below the line. So this is going to be on or below the line. For x is less than or equal to 9, similarly, this is going to be on or below the line. Now, my next inequality is x plus y is less than or equal to 8. So x plus y is less than or equal to 8. In this form, it is not always easy to identify what we really need to do. But what we can do is we can basically say the line that we're interested in is x plus y is equal to 8. And how do we sketch that line? We simply can take two simple values of x and y that add to give 8. So for instance, we can say that 2 plus 6 equals 8. So 1 point on the line is 2, 6. We can also say that 0 plus 8 is equal to 8. So another point is 0, 8. Is that clear?
Yes, sir.
So all we need to draw a line is 2 points on the line. I will just draw a line connecting those 2 points. So doing that, we can say that, say the point 0, 8 would be here, and the point 2, 6. I mean, those are pretty close. Let me try to find points a little bit further off. So since we use 0, 8, we can also say that 8 plus 0 is also equal to 8. Let me use a brighter color. So 8 plus 0 is also equal to 8. So therefore, this point, 8, 0, will also be on the line, right? So this is a point 8, 0. And we now draw a line connecting those, right? So let's start freeze up intro one. Right? So that blue line that I just drew, that line is the line x plus y equals 8. So this line is x plus y equals 8. But what am I interested in for the inequality? Now, sometimes it's a little bit difficult to realize when we have the equation or the inequality in this form. So let's do this. We can say that y is equal to 8 minus x. So y is equal to minus x plus 8. And what we're interested in is y is less than or equal to minus x plus 8. So that is the same thing as x plus y is less than or equal to 8. So having written it like this, we see that what we're going to be interested in is on or below the line. Okay? Everybody with me so far?
Yes, sir.
Yes,
So we
sir.
already drew 3 or 4 lines representing our inequalities, but they asked for 4. So they say label all 4 inequalities of R. Right? So the fourth inequality is this one here. This is the fourth inequality. So stop. Show. Wagon. I I in a session. So this next inequality, 2x plus 3y is less than or equal to 30. So just as with the others, we need to identify the line associated with it and draw the line. I will just need 2 points on the line, right? So let me just squeeze it here. So this line, 2x plus y equals 30. 2x plus 3y equals 30. If I choose a simple value of x, I could say x equals 0. So 0 plus 3y equals 30, which means that y is equal to 10. So we have the point 0, 10. And I pick another value of x. Suppose I choose, say, x equals, say, all right, let me let y equals 0 now. Can I get y equals 0? That will give me x equals what? 15, yes. So if I let y equals 0, I could say that 2x plus 0 equals 30. So 2x is equal to 30. So x equals 15. So I have my second point, which is 15, 0. And I have enough information now to draw my line. Just connecting those 2 points, 0, 10, and 15, 0. There are many other points we could have chosen, okay? But I just decided to work with those because it's easy to work with those. So I will locate the point 0, 10. App keeps freezing. It's frozen right now. Just give me a minute. Come on.